everyone, it's really good to see you all. So today we are going to simplify the core concept of object-oriented programming. So whether you are a beginner or just need a refresher, this video will break it all down for you. So let's dive in. So first, what is object-oriented programming? So in simple terms, object-oriented programming is a way to design your code by thinking about it as objects similar to real-world objects. The four main ideas in OOPS are encapsulation, abstraction, inheritance, and polymorphism. So let's explore each one with simple examples in C++, understand why they are useful, and look at some real-world application. So let's get started. So before we dive into each concept, let's quickly go over the four main principles of OOPS that we will be covering today. So first is encapsulation. That means bundling data and methods that operate on that data. Second, we have abstraction. It is simply hiding complex detail and showing only the essential features. Then we have inheritance, creating new classes from existing ones to promote code reuse. And lastly, polymorphism. That means allowing methods to do different things based on the object it is acting upon. So now that we know what the four main principles are, let's start with encapsulation. So, encapsulation means putting data and functions that work on that data in a single unit called class and hiding some part of it from the outside world. Think of it like a capsule that contains both medicines and instruction on how to use it. Now let's look the code. So here the car class is defined with a private speed attribute. The setSpeed method takes an integer parameter and sets the private speed attribute. The getSpeed method returns the value of the private speed attribute. So in the main function, we create an instance of the car class called myCar. We set the car speed to 120 using setSpeed, and finally we print the car speed using the getSpeed method. So this example demonstrates encapsulation by binding the data speed and the method that operate on that data, that means getSpeed and setSpeed, together while binding the internal state from direct access. So here the car class keeps the speed attribute private. You can't access directly from outside the class. Now encapsulation is like a bank ATM. You interact with it by pressing buttons. You don't see the complex process behind the scenes. It keeps your account details secure while providing a simple interface to access your money. Now moving on, let's talk about abstraction. So abstractions means hiding the complex detail while showing only the important parts. So it's like having a TV remote. You press a button to change the channel without needing to know how it works inside. Now here in this example, we have a coffee machine class that abstracts the process of making coffee. The details of how coffee is made are hidden inside private methods, and user only needs to call makeCoffee method. So the coffee machine class is defined with a public method makeCoffee and three private methods boil water, brew coffee, and pour in cup. Now the makeCoffee methods calls the three private methods in sequence to make coffee. So in the main function, we have created an instance of coffee machine called myMachine. So we call the makeCoffee method, which internally calls boil water, brew coffee, pour in cup, and finally prints coffee is ready. So this example demonstrates abstraction by hiding the complex detail of making coffee and providing a simple interface, that is makeCoffee method, for users to interact with. So here the coffee machine class hides the detail of how coffee is made. The user just needs to call makeCoffee and the internal steps are hidden. This is useful because it simplifies how you interact with the complex object. Now let's talk about a real world example. So abstraction is like a car steering wheel to turn. You don't need to understand the mechanism of the car steering system to turn the wheels, right? You just turns the wheel and the car turns. Now moving on, let's talk about inheritance. So inheritance allows one class to use the features of another class. Think of it like a child inheriting traits from their parents. So here you can see that the color of both mother and daughter are of same color, right? So this is an example of inheritance. And in a similar way, in OOPS concept also we have this. Now, let's talk about the code. So here in this example, we have an animal class with a method eat and a dog class that inherit from the animal class and adds its own method bark. So here the dog class is defined with a subclass of animal class and it has its own public method bark. So in the main function, we have created an instance of dog class called myDog, and we call the eat method inherited from animal class, and we call the bark method defined in the dog class. So here the eat method is inherited from the animal class and the bark method is defined in the dog class itself. So this example demonstrates inheritance by allowing the dog class to reuse the eat method from the animal class while adding its own bark method. So here the dog class inherits from animal class. This means dog can use the eat method from animal and it can also have its own method bark. So inheritance is useful because it's allow code reuse and makes your code more organized. Now let's talk about some real world example. So inheritance is like a new model smartphone inheriting features from the previous model. The new phone can call and text just like the old one, but it might also have features like a better camera and more storage. Now moving on, let's talk about polymorphism. So polymorphism allows the same function to do different things. It's like a word that has different meaning in different sentences. So if we talk about the word run, so run can be used in two sentences: run a marathon, run a software. Now let's talk about the code example. So in this example, we have an animal class with a virtual method sound and two subclasses dog and cat, each overriding the sound method. So the animal class is defined with a virtual method sound and the dog class inherit from the animal class and override the sound method to print the dog barks. And the cat class here inherits from the animal class and override the sound method to print the cat meows. So in the main function, we have created pointers to animal object, but they actually point to dog and cat object. We can call the sound method on both pointers. The sound method call depends on the actual object type, which is either dog or cat, not the pointer type, that is animal. So this example demonstrates polymorphism by allowing the same method sound to behave differently depending on whether it is called on a dog or a cat object. This flexibility allows us to write more generic and reusable code. So here the sound method behaves differently depending on whether it's called on a dog or a cat. So polymorphism is useful because it allows for flexible and reusable code. Now let's talk about a real world example. So polymorphism is like a universal remote. You can use the same remote to control different devices like a TV, DVD player or sound system. Each device responds differently to the same button presses, right? So that's our wrap. Today we have covered the 4 fundamental principles of OOPS: encapsulation, abstraction, inheritance and polymorphism. Understanding these concepts will help you write better and more efficient code. So if you found this video helpful, give it a thumbs up and share it with your friends, and leave a comment if you have any questions or topic you would like us to cover next. So thanks for watching and I'll see you in the next one.